Hello everyone, my name is Mohammed Shazila and I am a student of Architectural Engineering Department in Changyang University, South Korea. Today I am here to present the topic of drowsiness detection system using transfer learning. So here are the contents that I will cover in this presentation. The first one is the introduction, related work, solution, algorithm, and so on, and conclude this presentation. Here is an introduction why I feel need to develop this system and research on it. The drowsiness refers to the feeling abnormally sleepy during the day. People who are drowsy may fall asleep in inappropriate situation or at inappropriate times. And the hypervigilance reduces the capacity to judge and react in analyze the situation on a road. So and it is caused by fatigue or drowsiness. And the recently National Highway Traffic Safety Administration statistics show that the total 2.5% of fatalities during a crash is attributed or due to that drowsy driving. And in 2015, the total number of crashes related to drowsy driving was 72,000. So here is a video that how I am detecting the drowsiness of a driver. If the driver eyes are closed for some time, the system generating an alarm and showing the status of closed eyes or yawning, and it's showing the yawning of a driver. Or in an active condition, the system just displaying above the open eyes status. So here is a related work that already had been done in this field. So there are some problems found like lightning conditions. Sorry, lightning conditions frequently changing in darkness and brightness during the driving has difficulty for an algorithm to detect. And there is three types of approaches that were using previously. One approach is to seek the changes in vehicle behavior. Second approach is based on studies focused on using driver vital signs such as biomedical techniques like electroencephalogram to make prediction. And the last one is the approach used previously is computer vision to viewpoint of eyelid curvature and thereby identify them either closed or not. However, this system has lightning problems. So what I did, and here is my solution. I have used the transfer learning and the last layer of the last fully connected layer of the Alex network, and here is the block diagram or a flowchart which will explain how this system works. The real-time video is used to detect the status of the driver. Secondly, the face detection is performed using the Weiler-Jones algorithm. After the face detection, the eye detection is performed and pass this frame for the pre-processing. And after the pre-processing, this frame is passed to the AlexNet to check the status of the eye. If the eye is closed for the specified eye aspect ratio, that is eye aspect ratio, I have used the 0.16. If the eye is closed for the 0.16, which is the threshold value, then the system will generate alarm and the status show as the drowsy. Otherwise, the eyes are blinking, just blinking, and the status shows as the active. Here are some two algorithms that I use in this system. The first one is the Weiler-Jones algorithm for the detection in real-time video, but the training is slow. However, the detection of the face is fast. And secondly, for training purpose, I have used a stochastic gradient descent with momentum algorithm. Basically, it is used to update the learnable parameter in a custom training loop. The SCADM is a popular algorithm to perform optimization. As I have to classify three types of classification, that's why and it is a fast algorithm. So that's why I use the SDTM and the fully lost next layer of the Alex network. And here is the training, how the training is performed. The Pidin network, AlexNet is used for transfer learning. And as we know that the AlexNet can classify thousands of objects, this system performs three types of classification: the closed eyes, yawning, and the open eye. And the alarm generate on the closed eye and the yawning. The training data set is reduced to the 227 cross 227 dimensions RGB images, and our network is trained by the SGDM algorithm, stochastic gradient descent algorithm, which is popular for optimization. So here is the equation, which is in a for loop and continuously updating. Choose an initial vector, parameter, and learning rate. Repeat until an approximate minimum is obtained. Randomly shuffle examples in the training set by using this equation. So here is the W vector, weight vector, and that is basically a new weight vector. Calculating like this is an old vector, and subtracting with the learning rate. I have basically this is the learning rate. I have used 0.001 learning rate, and this is the function basically used to calculate the gradient. This is an cost function for the calculation of the gradient. So this is this equation is repeating for until the approximate minimum is obtained. And here is a table that shows that the epoch rates, iteration, and total time taken for the training. In the first epoch, only 10 seconds is taken, and the accuracy minimum mini batch accuracy was 39.06%, and learning loss was 1.9087. So the total time, the 15 minutes is taken, and the mini batch accuracy is achieved 100%. So which type of data set I have used to train my network? Here I have used the MRL I data set, which I have downloaded from the internet. It is an human eye and other 500 images of yawning. These 500 images I have generated my own data set for yawning and closed eyes and open eyes in bad light conditions or good light conditions. I have used MRL eye data set. The data set contains the eye pictures of 27 different persons, like 33 men and 4 women. The 1400 images of eyes used for the open eyes classification, another 1,842 images used for closed eyes, and the other 500 images of yawning made by me for yawn detection. And remember that this all in my data set 37, this is a data set based on the grayscale images. So first I converted them into RGB images and then train on a network. Original grayscale images are collected from the internet and resize them to 227 cross 227 and RGB. Here are some results. And that's for testing purpose. The mobile camera is used as an external camera to check the status of the driver. First, here I'm yawning. The system is detecting as the yawning. Here I'm just sitting actively, and the status is showing open eye. In the last, if I close my eyes, or eye aspect ratio is calculated. For example, here I use the 0.16. If my eyes close for the more than the threshold value, then the system will display the closed eye status and start alarming. The face is detected, and first and how this is performing. The real-time camera recording the video, and the face is detected, then crop it and resize to the 227 cross 227 and pass to frame to classify the status. It is a conclusion. Our method is robust for detection in low and high lightning conditions. As I earlier told, that the system is trained on various type of data set, like in a bad lights, good light, and with glasses, without glasses. So the system is capable of detecting the eyes whenever our driver is wearing a glasses. To achieve this, transfer learning is used with AlexNet And the achievement here is that the system is capable to detect the driver drowsiness as the system trained on various categories of images, such as bad light, good light with glasses, and without glasses. And one more thing is that in the future, this system could be extended and develop an Android application which can be easily accessible to the every driver as free of cost. So